Welcome, Math 10 students. This is Mrs. Parsons, and today we're going to be talking about applications of quadratic equations. So some good strategies that I have for solving these story problems. First one, ask yourself, can you draw a picture? Then can you identify what you're being asked to solve for? And then can you write an equation? If so, we need to determine if it's going to be linear or quadratic. So in my first example, it says one side of a rectangle is 4 inches shorter than 3 times the other side. Find the length and width of the rectangle if the area is 319 inches squared. So let's see if I can get my pen tool here. So one of the first things is I'm going to draw a picture. Okay, it says a rectangle. So there's my rectangle, and it says one side is 4 inches shorter than 3 times the other side. Find the length and the width. So it's asking me what the length is and what the width is. And it tells me what the area is. So let's say I call one side X. Then it says one side of the rectangle is 4 inches shorter than 3 times the other side. So I guess I should really call this one X. And the other one is 4 inches shorter than 3 times the other side. So 3 times the other side minus 4 inches. So I have an expression written for both the length and the width. Now another thing it tells me is the area. Well, what's one pretty basic thing we know about area? Well, it's length times width. So that's saying that my length, which is X, times my width, 3X minus 4, equals 319 inches. So how am I going to solve this? Well, I'm going to start by distributing. So that gives me 3x squared minus 4x equals 319. We know that it needs to be in standard form equal to 0. So I'm going to minus 319 to both sides to get 3x squared minus 4x minus 319 equals 0. And we can solve this two ways. We can solve it by factoring, or we can solve it by quadratic formula. Okay, I am actually going to use quadratic formula because if I multiply a times c by this, it's going to get really big. So it's just easier to use quadratic formula. And when I do that, with a being 3, b being negative 4, and c being negative 13, I get x equals 11 and x equals negative 9.7. So think about what we're talking about here. We're talking about the side length. Okay, if you told me the length is a negative number, it doesn't really make sense. So we know that my width has to be 11, or one side of it has to be 11, and the other one is 3 times 11, 33, minus 4, which is 33 minus 4, 29 inches, and 11 inches. In our next example, it says we throw an object upwards from the top of a 1,200-foot tall building. The height of the object measured in feet t seconds after we threw it is h equals negative t squared plus 16t plus 1,200. This is a perfect example of where we can draw a picture. So we're at the top of this building. Don't be upset if your picture doesn't look as good and awesome as mine does. Okay, we throw this object off the building, and you can see that this is half of a parabola. Where is the object 3 seconds after we throw it? So in this case, t, our time, is 3, and we want to know what h is. So we can just plug that in to our equation, 16 times 3 squared plus 16 times 3 plus 1200. You get your calculator out. Negative 16 times 3 squared plus 16 times 3 plus 1200, and you get 11,004 feet. When will it reach its maximum height, and how high will it be? So if we go back to our picture, our maximum height is right here at the very top of the parabola. And what is that called? That is called the vertex. So how do we find the vertex? It's negative b over 2a for the x value. So that's negative 16 over 2 times negative 16, which is negative 16 over negative 32, which is 1/2. So it'll reach its maximum height in half of a second. And how high will it be? Well, we're going to find out what that height is by plugging in 1/2. So negative 16, plus 1/2 squared plus 16 times 1/2 plus 1200, and we put that in our calculator, and when we plug that in, we get 1,204 feet. When will the object reach the ground? So if we go back to our picture, when it reaches the ground, we know that our height is going to be 0. So I'm going to put in 0 for my height. And we are going to solve this using the quadratic formula. And when we plug this into quadratic formula, I get 2 answers. I get negative 8.17 and negative 9.17. Now we know that time cannot be negative, so it is going to take 9.17 seconds for this object we threw to get to the ground. So here's a summary for those height problems. Where is the object however many seconds after we threw it? We're going to substitute in that value for t. When will it reach its maximum height or its minimum height? That means we're finding the vertex with x equals negative b over 2a. And then plugging that in to find the height. And then we're going to substitute, when will the object hit the ground? That's when we substitute in 0 for the height and then find the zeros using factoring or quadratic formula. So in summary, some options that you have, some really good tips, is to draw a picture, then write an equation. It might be linear, it might be quadratic, and then identify what you're being asked to solve for before choosing a strategy.